Right, I think we are live. Let me do a quick check. Right, since we're live on Facebook, sorry, YouTube, checking Facebook right now. Not sure if the link is working on Facebook, but I think YouTube is all good for now. Okay, hold on. Let me do one quick check. I have no idea how people do this live. Okay, right. I saw Tristan's chat coming in. This is good. Okay. Yeah, having some problem on Facebook. No worries. I think YouTube we're having there. So, right. Let's start off with today's Ruby Tuesday, number 73. So we have special guest today. We have Gui from Penang.
Hi.
Gui, you want to say a few words?
So I'm Gui. I'm the co-organizer for Ruby Tuesday and JavaScript Penang. So we are collaborating with the KL group for this meetup. Good to see everyone here.
All right, thanks, Gui. So today we have quite a few talks arranged for everyone. Let's go through. Today we are proudly sponsored by AWS Developer Accelerator Program, as well as Engineers.mind providing StreamYard, and of course KL Ruby Brigade. So Facebook page, the meetup page, of course everyone will know since everyone joined to the meetup page. The GitHub, if anyone's interested in some Ruby code, and as well as join us on Slack where we chat about Ruby. Right, I'm Gui. If you're expecting to see Tristan or Jimmy today, Jimmy is busy and Tristan is behind the scenes right now. So unfortunately, I'm running this solo live together with Gui.
Yeah, we have two Gui here.
Yeah. So we are live on YouTube right now. I don't seem to be able to get Facebook working. But yeah, if you're on YouTube, please feel free to chat. We can see the chat coming in through. So yeah, if you have any questions, let us know. I'll talk to the speakers about it. Right, moving on. I didn't receive any hiring shoutouts, but if anyone is interested, please reach out to us and we can do a hiring shoutout in the stream. Okay, our first talk is the AWS Community Program by Faz. I will drop Faz in. So we'll be talking about a quick one about the AWS Community Program.
Yep.
Go ahead, Faz.
Yep. Thanks for that. Hey everyone. I'm Faz. I'm from AWS Amazon Web Services in Malaysia. Just a quick brief on me. I'm a senior solutions architect for startups in Malaysia. I've been working with the industry for 16 years, worked across multiple corporations, SMEs, consulted for startups. Some of the folks may know me over here, people who are tuning in already. And I've been engaged in software development for quite some time. I've also been very prominent with the tech community over here. Engineers.my is usually my haunt. If you ever need to reach out to me, you could just holler over there and I'll be there. So I just wanted to introduce a program that we are running in Malaysia. So this is AWS Developer Accelerate Program. And we have a couple of things, initiatives we do under this. One of the things we do is that we have a Connect program where we live stream live coding. So we have specialist essays and other solution architects from across ASEAN who come in almost once a week and do live coding sessions on different topics. And we've also started branching out into localized languages. So we have one right now happening in Bahasa, Indonesia. If you guys are interested in Bahasa Melayu, just put it in the comments and we'll definitely look at for that. So we have different topics being covered right now. We have things on Cloud Development Kit, which is surprisingly one of the topics today. And then we have things like AI and machine learning, how to build a web front end and back end using Amplify, and a lot of other topics. So do go on to our Twitch channel. I'll be sharing the link in the comments later because I conveniently forgot to put it in the slides over here. Another initiative that's been run in Malaysia is actually for folks who are new to the cloud And I've been running every Friday night a cloud session, like a beginners to the cloud kind of a series. We call it Going Cloud Native. This is being done with two unis. So we have the Help Tech Club and also the IIUM Tech Club, who's helping out in this. And we've been doing this every Friday. We just stopped it because some of the students are having exams. We'll be starting immediately after the 15th again. So if you're interested in this program, also you could put it back in the feedback group, and I can share the link for joining. And we have a Telegram group running separately for this. So even if you're new to the cloud and you're not sure how to start with this, do join in. It's good for basics. So with that, I have a special offering for you guys, since RubyMai was pretty awesome to take me on today. We have a feedback form because we want to find out more from the community, try to understand how we can help you best in doing things on AWS. Whether you're running certain projects right now, are you looking at maybe hosting a certain website for your business or anything else for that matter. We have a form, and we'll be sharing the link later. And the idea is that if you do sign up for this, the first 20 registrants will get $20 of AWS credit. So just take this as a goodwill from our side that you'd actually use this to build up an actual application of yours and do some good stuff on AWS. So here's the link, and we'll be sharing it again throughout the talks later. So do use that, and it will be useful. So with that, signing off. Thanks.
Hey, Fast, thanks for reaching out to us and talking about this. For the cloud native event that you talk about, let's say, like, since we are a Ruby community, right, and let's say we're writing on Rails and we want to learn, like, for example, deploying on ECS, for example, which session would be the best session for us to attend that?
Okay, yeah, good one. So we have the app development session. So what happens is security is basically the last session we're doing in terms of the basics of the cloud. Which we'll talk about IAM and all. And after that, we are going to start moving more towards app development. So I'll be starting with a series, a sub-series in this called Modern App Development, where we talk about how to build an application deployed to maybe Beanstalk and containers. And then after that, move on to DevOps, have a specific topic just on containers, then serverless. So I would suggest to start with app development after this. So the dates are a little off because we decided after the poster was made that we're going to have a 2 weeks, 3 weeks break. So I'll be updating this later and then sharing it in the Slack channel also for folks to see. So app development would be the best one to start with, I would say, because I'll be touching upon a lot of constructs of how apps currently are developed to be cloud native and how it's different from how it was in the old days. I'll be touching upon different parts of DevOps and other things, and also so that it gives that whole cohesive picture of how a developer, when they build stuff, it's not just about writing code on their laptop. They need to also understand. Where they're deploying to, and understanding the systems, understanding where it's going to be hosted. And if you're in a team that has the motto that if you built it, you fix it, then more the matter that you need to understand the architecture also really well. So I would suggest app development. Yeah.
Right. Yeah. I guess another plug I can do for serverless is that was it this year? Yeah, this February. AWS supports Ruby 2.7 on serverless, on Lambda specifically. So
Yep.
I guess that's another incentive for us to join this. Again, thanks so much, Faz.
Thanks a lot.
So this is the link that Faz talked about, right? The first 20 who sign up for the link will get $20 AWS credits. Am I correct, Faz?
Yep.
All right. So this is the time to snag the freebie. All right. Once again, thanks so much for joining us, Faz.
Yep. Thanks.
All right. Let's move on. Next up, we have AWS CDK set up for Ruby on Rails by Kane. Gonna let Kane in. Let's see how this goes. All right, Kane.
Hello. Okay, sorry about the two screens.
Right. I can remove one screen.
No. Keep both, because one of them I'm screen sharing. So just give me a second. Yeah, screen share. Can you see my screen? Are we ready? Sorry.
No worries.
Is it sharing my screen? Can you see it?
Yes, it is. Sorry about it.
Ah, there we go. Okay, so start presentation. Okay. So as mentioned a second ago, this is the intro to AWS CDK, and my screen's just crashed. Infrastructure as code. And my name's Kane, Labs, and I also have my own company called Yggdrasil Cyber Solutions. So just before we continue, I want to say a great thank you to Faz for AWS sponsoring for this talk. So it's a real help. You share the link that was done before, register on the link before, and as I said, you get the $20 into your account. So today we're going to cover what is IAC, why we should use IAC in our projects, some examples of simple Rails projects, and then some tools that you can use to speed up this process for you. So what is IAC? So IAC is infrastructure as code, and it's exactly what it says. It's your infrastructure in the cloud based on code using reusable components. Now, this one is the most important, reusable. So if anyone's ever used AWS before, they'll know that it takes a long time to manually set everything up, from your VPCs to your subnets to your database to your S3 buckets, including pipelines, etc., etc. So it's quite a complex thing to do, and if you have to keep doing that like every day, you end up spending a huge portion of your company's budget just setting up a server. So AWS came up with, not just AWS, a few others as well, but they came up with IAC, and they use TypeScript, JavaScript, Java, .NET, and Python. And I believe there's a few other languages that are in the works to come out soon that will help you if you don't know these languages. So why do we in my company use IAC? So as I mentioned before, setting up manually takes a long time. And if you can use IAC, once you've got your components set up, it's very fast. You know, you get a client tomorrow and you can have their VPCs, servers all set up within half an hour because your code is there. It also is easier to update and upgrade. So rather than going into the AWS console and choosing, say, your RDS instance and going from a medium T2 instance to, I don't know, a large T2 instance, or even further than that, you know, they've got like a huge list of instances that you can require. So oftentimes this can be quite troublesome, going through, making sure you choose the right one. So with IAC, you can just update your code, and once you've done that, you upload it to the server, and it does all the work for you. So if you make a change with Git, you commit it, and then you can roll back. So let's say you merge a branch into Git. You can revert back to a previous setting and everything goes back to as it was, and you can continue. And a better example that you might all understand is Rails DB. So when you do Rails DB migrate and you create some migrations, and maybe you missed something, you got something wrong, or you just don't like the migration, you can do Rails DB rollback. And what that'll do is that'll roll the database back to the previous setting, or to how many, because you can choose how many steps to go through. And it just makes things easier to maintain. So you can do this with IAC as well. The CloudFormation console always keeps to date how many times you've pushed your records to the cloud to be able to roll back. It's cheaper to set up. So like I say, if you're paying a DevOps, I don't know, 100 ringgit an hour to set everything up for you, you know, you don't want them doing that manually. It's going to take a good few hours. The prices will go up more. And if you've got, say, 5 projects, that's a long time to do it. So using IAC, it's much faster. And you can implement that into your project so that when your developer is working, if they need to make a change to your code, they just go into the infra project folder and modify that. Like I said, later on, I'll show you a bit more and you'll be able to see it. Billing services are much easier to calculate with better accuracy as well, because it's all done with code. You can tag all of your resources. So your VPCs, your RDS instances, your Elastic Beanstalk resources, your S3 buckets, everything can be tagged with your company's name, your project's name, and then any other details that you wish to be tagged. So that when you do go into billing, you can say, okay, choose this name and show me the bill for everything that has this tag, and then it comes up. So it's much easier for you to then bill a client rather than having accountants sit in your office go, okay, this VPC used this much, this one used this much, this blah, 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 and then calculate it manually. It just gives you a nice, easy page where everything can be done. The billing, I'm not going to be able to show you today, I'm afraid, because it's a bit, I have too much confidential information inside my what's going on? Inside my AWS. So I've not been given permission to share that, but I will show you how everything looks at the end and how you can do it. And no, that's the last screen. So let's get into it then. What does IAC actually look like? So, so 1 second. It just got in from lunch. I was setting it up and then had a problem with the microphone. So we'll do this one. We'll CD. Documents. Projects. Ruby meetups. C Rails. Sorry, just give me a second here. Just start everything up. Okay, so we'll show you the Rails CDK first. So to use AWS infrastructure as code, there's a few things you need first. So the first thing that you need is AWS CLI, which is a command line interface. So you would do that with Node.js. So obviously you're all going to have Node.js installed on your system already, hopefully.
Ken, sorry to you.
Yeah.
But can you zoom into the code a bit?
Yeah, sorry. Let me. So I'm on a laptop that is like 15 years old. So just bear with me. It's crashed. Come on, get rid of this. There we go. Zoom. Okay, is that better?
Yep, thanks.
You can see it, or?
Yes, I can. Can you hear us?
Can you hear us?
Yeah.
Yep, right.
Yep,
Thanks.
right. Thanks.
So you can see that now?
Yep.
Okay. So, as I was saying, so you need AWS CLI to run, and that uses Node.js. So you just do npm I G and AWS CLI. And once that's installed, that'll give you all of your commands such as CDK synth, CDK deploy, etc. We'll come into those commands later, but it's just good to know that they're there. You'll also need to export your account ID. So you never want to commit credentials to your code because that's just bad. Everyone knows that. So you do export AWS account ID, and that equals, I don't know, whatever your account ID is. You can find that in the AWS console. Oh my God, this laptop. So you go to support, click on support center. And then you get your account ID at the top. This is the fastest way I've found of finding it. So AWS has a lot of different services. They provide all sorts of really cool things. I mean, if you're into satellites and things like that, you can even create your own ground station as a communication device for any hobby satellites that you create and launch in space. And it makes it much cheaper than you having to develop your own. Also, because Amazon is global, you get to use your ground stations all over the world, and it makes it really cool. But what we're going to focus on is the CloudFormation. So the CloudFormation is not only available with AWS CDK, it's also available on its own where you can develop, but it's not as user-friendly as CDK, and it's not as customizable. There's a lot of things that you have to make sure you've got specifically right, and you can't commit your IAC to your project. So if you look here on this left-hand side, you'll notice I've got an infra folder and a bin, and all this is infrastructure, so your IAC, and I can commit this to code. And whenever I need to make a change to any of my cloud infrastructure services, I can come into this cdk.ts file and I can find whatever I'm looking for to quickly update something. Then I'll do a npm build and a cdk synth and then a cdk deploy. And what that does, npm build runs the command tsc, which then does some cool stuff in the background that helps build all your assets that you need. CDK synth will actually synthesize your TypeScript code or whichever code you've chosen, whether it's Python, .NET, etc. And it will create a CloudFormation stack from that. And it's that you actually deploy to AWS. So here, there's a few things that you have to have when you're doing it. So you must have your environment. So if you notice on this project, we're in US East 1, and my account number's been muted out. But this is where you would either do, env AWS account ID. Dead simple like that. And then region is whichever one you're going to be putting through. So actually, this is not a good project to show you because it's already completed. Let's start with the real basics, Rails CDK. So when you want to start your own AWS as IAC infrastructure code using the AWS CLI, you will just do CDK init, and then you choose the language that you want to use. And that's it. And what this will do is this will set up a folder structure that looks like this. So you have your bin, your lib, and your test. So test, self-explanatory. Test, you can test all of your CDK to make sure that it is functioning the way it should be before you even try to deploy it. Now, bin is your entry point. This is where, when you use CDK synth and CDK deploy. It's going to look in the bin folder of your project to look for this root entry file, and that's what it'll load. So if we go into this now, come on. There we go. You'll notice we've got all of these that are all local, apart from the AWS core and any others that have got @AWS in front of it. The rest is all localized. So we just import what we need into here. We have to import core because that is how AWS runs. Without the core, we're not going to be able to do anything. So then what we do is we'll create a new app, like it says here. Don't worry, the things above I'll explain in a second. So once we've got the new app, we actually want to create a VPC. So with the VPC, we can do two things. If you have, like my company, we have one VSC for internal, and then we have a second VPC for another client that was very adamant that they had to have their own VPC. They could not be shared with anybody else. So we obliged by those. So there's two options. You can create a new one, or you can look up for a VPC by ID and import that into your project. When you do that, you need to make it as a stack. So the way it works is I could have done this as one whole stack. So the VPC, the RDS, and the Rails could have all been in one stack in the CloudFormation. So if I go into my, there we go, services, oh, it's there. So I go into my CloudFormation. You should see some here. When it loads. Okay, so you see all of these on the left-hand side. You've got EQ, EQ RDS, EQ VPC, EQ Rails Pipeline Prod, EQ S3 SPA Pipeline Production. So each one of those represents one of these. So the VPC stack, oh my God, what are you doing? So the VPC stack would be this one down here. Your RDS stack is the one that's just here. And the Rails stack is here. So the Rails stack actually is the EQ. So why have I done it with individual stacks when I could have done it as one whole stack? Well, the reason for that is the VPC and the RDS, they are two things in your cloud server formation that are very unlikely to change, which means that once you've created it, you're going to leave it. That's it. You know, it'll be once in a blue moon you'll make a change to either of those, and they take a long time to create. So you want to always add them into individual stacks so that you can save yourself some time. And it also means if you really need to destroy your Rails application, you know, and the front end of it as well, you can quickly destroy them, rebuild it, but you don't lose any of your client's data from the database. It also means you don't have to create new stacks with different names, but still using the RDS instance from the other stack, which is possible as well. You just need the RDS instance ID, but I prefer to create everything as normal. So when we create a VPC stack, you'll notice it takes in app, which is the one we defined above. This is the name for the identifier. Now, the naming conventions, you need to be really careful when you do these, because some of them, they require to have no special characters. I forget exactly which one it is. I think it's the database. You cannot have any hyphens at all. It doesn't like it, or special punctuation, things like that. It just screams at you. Other ones do not like the front letter being capitalized. So, yeah. So you just make sure you follow the naming, but before you deploy, it will actually tell you an error that you've named something incorrect and it doesn't like it, so go back. The env is what's above. So the env, your application, it needs to be told where it's going to be deployed. So by default, if you don't supply an env, it'll actually crash. It won't work at all. You must supply the environment. Now, again, with the environments, there are some things that are little nuances that you have to be aware of. You can set up a VPC in any region that you like. But when you're using, I think it's the AWS secrets and the certifications, they must be in US East 1. It's where it searches for them by default, and it can't be changed. So you must make sure that when you create your certificates, so the SSL, so that your app is running fine with HTTPS, this is all done in US East 1 and cannot be changed. It's by default. The next, I pass an app environment. So I give it an app name, the environment, whether it's production, staging, testing, whichever one you want to use. These two are optional, but it is good to add them. Later on, we'll see why, because it's about the tagging that we saw earlier. So if we look into the VPC stack, we start there. So the VPC stack, if you look here, it's very small. And it's because AWS is brilliant. It's a really good piece of kit, and it's mostly pre-configured before you even go in. So you're unless you really need something difficult, something more complex, you just stick with the defaults, and it works. It's brilliant. You just import the VPC and IPv4 from AWS EC2, which is it's the module that holds all of the VPC things. So to do this with npm, you would just do npm I and then at AWS EC2. No, sorry, AWS CDK EC2. And that will install the library for you so that you can use it. If you're ever unsure of what libraries you need, you can go to their documentation and it will always tell you what they need. So if I do, okay, let's see, I want to use the AWS pipeline feature. And I'm not sure what the library is. I'll just do a quick Google search. I'll look down, I see code pipeline example. That's a good start. We click on this one. Yeah, when it loads. Come on. No, this is not the docs. There's a different documentation. Let me try and find that. Is it this one? Ah, yes, there we go. So when you start doing it, you'll be able to open up the AWS CDK docs, the links above here. But as you saw a minute ago, you can do a quick Google search and it'll come up. And then here's the pipeline modules. So for every language that you use, if you're using Python, you use AWS_CDK.pipelines. For TypeScript with npm, it's just at AWS CDK pipelines. And it's as simple as that. You literally look for the module that you're trying to use. So let's say I want to use S3. I go in, I click on the overview, and again, I get all my S3, and there's the library. So I would just copy and paste this into the npm install command, and npm I like that, and hit enter, and it'll install that for me. You won't be able to use the S3 module without installing it into your npm project. It must be installed. Its core is the basics. It's what gets everything running, but for the things that you need, you must install them. And it just means your node modules are going to be very small and not extensive, because you're only installing what you need to use and not everything that Amazon has to offer. So we go back to the code. Come on. So then what you'll see is I've got base stack and base stack props. So as is with every development lifecycle, dry is good. Don't repeat yourself. You know, if you're typing the same thing 10 times, clearly it can go into its own class and you just import that class. And AWS CDK, no matter which language you use, it runs on the same principle. So when you create stacks, your stacks are always going to be the same. Then they're not going to change very dramatically, the base stack. So you can create your initial base stack and then import that. So as you notice, it extends our base stack. Here we've got a attribute accessor. So we'll be able to access the VPC that we've created in our main bin file, and we'll show you that later. But first, let's have a look at this base stack. So base stack is here. So this is where the magic happens. In this base stack example, I handle all of my tagging. So anything that is going to be under my stack that I create will have tags against them, and tags help you with billing, because if you've got, like you saw earlier, there's in my cloud formation, there are so many resources on the side, it can end up getting quite complex. You know, how do I know? And this is just one region. You know, all my other regions are all packed. So if we go and look in the other ones, when it comes, come on. Sorry, I'm in typing, so the internet here is not very good. So we see here all of these stacks. Now you imagine trying to go through these, click on each one, and trying to figure out how much each one of these used in data and how much you have to charge your client. It's very difficult. So the way we do that in our company is we use tags, and we just tag all of our projects. And that way, when we want to go into our billing, we're able to say, okay, Scout Mob, we need to bill them this month for their VP services. Go into billing, click on tags, click on your tag name, and then you'll get a list of all the resources that are under that tag, and you'll be able to figure out and calculate exactly how much each one costs, so that you can then directly bill your client. Makes things much simpler, much easier, and it's less manual work. It's mostly automated. So if we now go into conventions, you can see how I've done that. So constructs, conventions. So here I take in @env, and @env is on that first bin that we showed you. You got here. So this is the app env. It's got the name, the environment, the org name, and the author. And it'll take each one of these and it'll tag the application as needed. So you can see here, tag.add construct Rylabs app name, and then this .app name app-env app name, and that'll grab everything, all the details out of there, and tag each one of your projects with the associated tagging. So I'll show you what that looks like. Go back to the one I have permission to share. Come on. So click on EQ. Where's this one? There's your tags. So if you notice there, we see all these tags: app environment, app name, author, org name. And these make it much easier to see which stack belongs to which. You can also filter them by the tags as well. So it makes it much nicer and much easier to handle rather than going through. So we'll go back to our code. So now, after we've got the base stacks and we've done the VPC, so as we saw before, the VPC, dead simple, it was just import VPC, IVPC, give it a description, apply the props, and then set this.vpc to equal your new VPC, and that is your attribute accessor. So when you go into your root file, when you need to use the VPC, so we want to deploy the database instance inside our VPC. And to do that, we need the VPC. So to get it, VPC, and then you choose the VPC here, VPC again. So the 3 VPCs, and that will give you, that will supply the RDS stack, which is the database instance, with your VPC on where to deploy. And it'll also pass it the app environment, so it knows, you know, where it's, what it's got to be and who it's named. Again, you must pass the env because every stack requires env. No matter how many stacks you create, if you create 50 stacks, you must supply it with an env environment so that it knows where to deploy. You can use multiple envs, but you would have it as env1, env2, env3. So let's have a look at the RDS stack. So the RDS stack is probably one of the most complex things that I created in IAC. It's the database, the documentation is quite extensive, but it can be quite intimidating, especially if you're not too sure what you're doing or how it needs to be done. But just I'll run through this. So we basically create some database instance. We take them all from the AWS RDS instance. So the module that we looked at earlier, we bring in some other objects, the base stack, and the secrets manager. Here we set some defaults for our RDS. So we can override the defaults if we need to, but again, it's not required because AWS CDK, the defaults are actually pretty good. They're pretty extensive. Here you'll notice I've got my interface, and this is what accepts the variables that you need to send. So as I mentioned earlier, let's say you're running a database instance. When you're in development, a default database instance is good with T3 micro. You know, you could even go smaller than that if you wanted to. I think there's a T1 and T2 micro. The T2 micro is free to use up to a certain point. So with this, I can create a quick database that's not going to cost me too much in terms of resource usage, but it's going to be fairly scalable. Because this code would be stored inside my application project in an info folder, whenever my database gets too big, I can just come into this file, go into the root, find where the database has been created. So the RDS instance here. And I can do instance class joy instance class. I need to go back to the other one. I forget what that one is. Go down, scroll down. Here. So when I want to update my RDS stack, I can literally come in, type instance type, and set it to the instance type of instance class T2 and instance size medium. And if I want to, let's say we're monitoring our application and the database has got a bit too big, it's no longer, we're reaching our limits and AWS is sort of screaming at us. We can literally just come in and change it to large. So now we've got a T2 instance of the database, only it's running a large instance instead of a medium instance. Now, if you were to do this manually by code, it would take you a good half an hour. For someone that's not quite experienced in this, to go through, to find it, to update it, etc. In Heroku, which also uses AWS, that's where their services come from, you can just go in and you can update your database instance to a larger size and you get billed accordingly. Whereas, you know, this one, no need to go anywhere. You just go into your code, which if you're the developer, you're going to have open anyway, and just quickly change it. So we go T2, T3, and that's it. It keeps it nice and sweet. Things are where they're supposed to be. You don't have to go around looking in different places. I mean, you've seen my internet connection now. It's so slow. Imagine you trying to build an AWS infrastructure using this computer and this internet without IAC. You're going to be there for ages, waiting for the pages to load, waiting for the resources to come through. Then you've got to click through and find everything. It takes a while, and time is money. So the faster you can do these things, the more money you earn for a less amount of work, which is good. Everybody likes that. So delete this. And again, so there are interfaces, like we said before. We have our defaults, then we have our what we can accept and what we don't want to accept. So sometimes people want to overwrite certain things. Sometimes people just want to leave it for the defaults. You know, I stick with the defaults for most cases. Okay, here is where our conventions came into place. The reason we actually created this conventions file is because of what I mentioned earlier with the naming conventions. Certain things like camel case, some things like underscore, some things like path. You know, it's different ways of transforming the name to be what you need it to be, to help you get around all of those naming conventions. And you just have to remember which one it is. You can call up your conventions and just call that and have it format the text for you. Go back. So removal policy, I'm not going to go into all the specifics on how to do all this because I think it'd take a lot of time, and I'm not 100%. I worked with a team of 4 people to help, well, 2 people to help develop the tool that I'm going to share with you later. So it's quite complex, but like I say, you go through the documentation. If you already understand your databases, it's quite easy to get through. It's not difficult to learn. It takes, I think this took me about a month to learn in total, reading and testing. Testing does cost quite a bit. That's one thing I will say. So luckily, thank you, Amazon, we've been given the opportunity to get $20 promo code for our AWS instances. Use that, because when you are developing your CloudFormation and you're developing your AWS CDKs, it is going to cost you money. For every VPC you create, it is going to cost you. As soon as you're finished, if you're not using them, destroy it. Then your charges are reduced dramatically. So it makes it much better for you, especially if you're learning these things and you need to keep deploying, deleting. You know, these are resources from Amazon that you are using and you are being charged for. Some resources are free, like Elastic Beanstalk. Elastic Beanstalk is free for I think every project that you use. It's a really good little tool. Yeah. So remembering the conventions and how they work is very important. It will tell you when you upload it, but it's just good to remember, because otherwise it doesn't like it. Here you can notice excluded characters from the database password. You can't use any of those characters inside your password whatsoever. If you do, it'll come back as a false, and it just won't work. There's another thing I wanted to mention. Yes, secrets. So as you can see, we are using passwords and other things inside our what's it? This is a development, so none of these are going to work in our project. But if you notice, the password actually takes the secret. So if we go into, is it constructs? I believe it's constructs. Oh, secrets manager. No, I won't explain that. So secrets is a module in AWS where you can store all your sensitive information. So if I click on here, or even go in here, let's go into the documentation. AWS secrets. Yes. There. Why is it doing that? Oh, why are you like that? So, Secrets Manager allows you to store all of your variables like you would in a Rails project in a Heroku using env. So rather than having any passwords or sensitive data inside your code that's been committed to Git, you use Secrets Manager. And what that'll do is that'll store your passwords secretly, and when you need to reference that, you can do as is with this code, like the example snippet, and it just gives you a peace of mind. You don't have to store your password in plain text inside of your project. And it also means when you're trying to access that secret, it can't be done unless you know all of your details. Like if you've got your keys and whatnot to your AWS account, then your secrets are compromised. But in which case you'll change all of those. There's many ways of getting it. You can use the secret arm. You can use an ID to grab it. But I prefer the way that we do it because it's just much simpler. And what we do, where did it go? Is we just create a new instance of the secret. We give it the name of our app. So this is not the actual password. This is the name of what we want it to be. So, yes. Also remember the name gets truncated by Secrets Manager. So keep it short. Don't make it too long. Too long, doesn't like it. And what this is doing is literally it's accessing the Secrets Manager to grab your password, to put it into this file when you use CDK synth and CDK deploy. And again, so we set the username, the password to equal what we've just had here. And then we create our database instance. Now this is the magic, I would say. This is where you're actually creating your database, whether it's MySQL, Postgres, Azure, there's many you can choose from. In fact, I think AWS has a nice list of where you can go. No. Ruby Meetup. Oh no, I didn't save it. Oops. But if you go to the documentation, you can check inside and you can see all of the resources you can use. It's very well documented. You can even just do it from here. You can type RDS. Oh my God, this laptop. No, someone. Oh, mute one mic. Wait, you shouldn't be able to hear two mics. You should only be able to hear one mic. Like the laptop doesn't have a mic.
Right. First was saying because there's an echo whenever I speak. That's why.
It might be the room I'm in. I'm in like a large empty room. Sorry about that. But we'll just in case, I'll mute that one as well. Oh man, I really need to invest in a new laptop. Oh my God. Yeah, we'll leave that. Right. So where was I? Yeah. So once you've set it all up, like I said, we use mostly defaults. So once you've created the database instance, it's nearly 100% default. The parts that aren't default are things like your backup retention, but even that we have a default on that one. But I suppose, yeah, the default is something we've set actually. So the backup retention, we made it 7 days, and that's every 7 days it'll back up and then delete it after 7 days when it's run out. Security groups. I'm not going to touch on security groups this time because I think that can take a long time. What I will mention about security groups is it takes a long time to protect your AWS instances. So for instance, let's say I'm the boss and GUI is my employee, okay? And I want to give him access to my AWS account, but I don't want to give him full access. I would go in and I would create all of my security groups. I'd create all of my permissions and whatnot, and then attach that to GUI's account so that he can then go in and only look at things that I've given him information for. And then you can export that and attach that to each project. So with this project, we actually haven't done that. We've set them up as scratch because this one was when I was learning, and we stick with the defaults mainly. Oh my God, this laptop. And we add the security group to the VPC. And that's about it for the RDF. Now, the next one that is actually Rails specific is, I'd say, the Rails stack. So in Rails, you'll notice we import the Elastic Beanstalk module because really good, helps keep our app in check. We're able to check its health and do all of these wonderful things with it. And it's free. It's free to use for every app. So it's always a good idea to have that. Then we've got our Rails app options, and we set some defaults along with our Rails environment. And again, we're using our base stack and our base stack props from earlier. So that includes all of our tagging, so we don't have to go in here again, tag everything with the resources so that we can do billing easier later. One thing I have noticed with this one is rather than being called what we set it to be called, it ended up being called EQ. For some really weird reason, I don't know why. I think it truncates the name on this one. I'm not 100% sure on that one. But our app name is not EQ. Our app name is EQ app. It's much longer, but yeah, it's a bit weird on that one. And what we do in here is we set our app environments. We set up our EB app, so CFN application. We get it. So this one is important. We need to set up a starter application bundle. Now, I don't know if this is because I'm not smart enough and I'm not well versed with AWS CDK to know how to do it correctly, but for our apps, we had to create a starter app, bundle that up straight away into an S3 bucket, and then use that. And once we got that one, we were then able to upload our actual source code, and it ran beautifully. So again, I'm not too sure if this is because I'm not smart enough to be able to do it correctly, the correct way of doing it, or if it is actually a EQ issue itself, EQ, AWS. And then here we construct each specified environment. So with this CDK, I can actually create three environments all at once. I can do production, staging, and testing. Now, what that means is at the top inside the Rails CDK, where it's got production here, if I turn this into an array and I add staging and test, when I deploy this application, each stack will actually go through and see each environment and go, okay, this one we do this, this one we do this, and it'll develop all of them all in one shot very quick, which is brilliant. Imagine having to create your production, staging, and testing environments all manually, all at the same time. It would be a nightmare. It'd just take you far too long. So with this, I can create an array, add the three, and then for each in-app environment, create my Rails app environment. It's worth noting that VPC and RDS, we only create one, and we use that one for production and for staging. It's a no-no. You shouldn't really do it, but we've got it configured so that each database that is in our instance is password protected and kept together. So I only need to build one RDS instance for each of the app environments. Whereas with the Rails app, because it's going to be different with staging, production, development, testing, I do want to create those environments. I can get away creating EQ development, EQ staging, EQ testing databases within the RDS instance. That's not a problem. But with the Rails app itself, that you really do want to separate, because this is the one that gets attached to your Route 53 and your AWS Certificates Manager, so your SSL. So then there was some, so if we look in the app environment, here we're creating all of the necessities for our Rails app. So being able to connect to the VPC to get into our instance endpoint, we can set up a security group here. This will also work for each environment that we create with. Again, we add our conventions so that we can tag everything. We have our session access so that we're able to access our Elastic Beanstalk session. And then we've got our EB environment. Here we have to supply our VPC because, again, it's connected to our VPC. We set our build environment vars. So what these are is in Heroku, when you go into your project settings page and you go to your environment variables, this is what that is. So rather than you having to go through your console to manually enter, you can come into your code under, in this instance, EB environments, and you can set your build env vars, you can list them all down, and then you can give each one the value that you need it to be. This way, there is no navigating through your console. There is no going from one page to another page to another page, especially if you've got 3 environments, staging, development, production. If you have those 3 and you need to go in and change each one of those environment vars to be the one that you want, that can become a nightmare quite quick. So this makes it much easier, much simpler, and we just have a function here that allows that to happen. Again, I've got something I can share with you later, so you won't have to do all this from scratch. You'll be able to use a lot of the work that we've done. These are all your option settings for for EB instances, auto scaling, things like that. It would take me a long time to go through each and every single one of these of what they are, because my memory is quite bad and I'm not good at remembering it off the top of my head. I'm forever flicking between documentation. So this one also is what you need. The add depends on just makes it so that this construct depends on another construct. This will not work without that construct. No matter what you do, it just won't work. Even if you try and do CDK synth, it will break and not deploy. Our Rails app defaults. So here, this is the instance type. So this is not the VPC or the RDS. This is your EC2 instance. This is where your app actually runs from. So when you go to www.google.com, and you click on that, that is a T3 micro. Google won't be T3 micro, but it's you get the point. The solution stack name. Oh, yes, that's a point. When using Elastic Beanstalk, do not use Ruby 2.7. It does not work. It's not been updated yet. As of 2 weeks ago, we had to downgrade to Ruby 2.6. So if you are going to start trying this and you've got a new Rails application, just be mindful. Ruby 2.6 is good. Ruby 2.7, not quite yet. You're going to need to wait a few weeks or months. Yes, Gray.
Okay, in the essence of time, is there anything you would like to wrap up?
Yeah, I'll show you the project that I wanted to share with you all. This one you can all download yourselves and install. So it is... Yeah, give me a second.
Right, in the meantime, maybe anyone has any question, they can post it through YouTube or Facebook.
There. So with this, you can install this with npm. So you just do npm I install at Rai CDK tools, and then that will install this tool for you. And what it is we created a VPC, an RDS, the pipelines, and the Elastic Beanstalk deploy for Rails. And what it means is you can just import these tools, import into your project to create your stacks, and then deploy. There's no need for you to go through and type everything yourself. There's no need for you to figure out all the conventions. You literally just install the things that you need and go. If you do need to install a new or create a new stack that isn't available, you can import our base stack from the node modules and then create your stacks on top of that so that all your naming conventions, everything are on top.
I think Kim probably would have removed himself from the stream. Oh, let me get a hold of Ken. I hope he sees this message. Ken, we can't hear you if you can hear us. Your phone is dead?
Can hear?
Yep, we can hear you now.
Yeah. So the project is open source. Anyone can contribute to it. Yeah, this laptop's crashed. It's dead. So anyone can add to it. It has the core constructs for you to build your Rails application using AWS. And I think, yeah, without showing you, I can't really explain anything else. I have to wait for this computer to what's it?
No worries. Maybe you can share with us the link later, and we can put it up in KL Ruby, so everyone can reach out can see where the project is.
Yeah, sure. Any questions?
I don't see any coming through from Facebook or YouTube. So yeah, I guess we are good.
It's a pretty basic overview. Like I said before when we were discussing the project, it's very difficult to explain all of this in 45 minutes. It's nearly impossible. It took me 1 month to learn like everything that's in this code in the first place. So trying to explain all of that it's a nightmare. The main things I would say to take from this talk are productivity. So it really improves your productivity as an employer. It gives you more time to focus on the code of your project and not the infrastructure. It makes things reusable. So you can just create it once and you don't need to keep writing it over and over again. Maybe just a few little snippets you need to update here and there with changes to the CDK. It makes billing much easier. And yeah, all around actually, it just makes your life much easier. And for those of you who are using Heroku is using AWS. All their services are built upon AWS services. So their databases, their hosting, it's all part of AWS. So if you're using Heroku to host a Ruby on Rails application, you're actually using AWS. So it might be a good idea if you've got a lot of clients to start learning IAC, add that into your project, and away you go.
All right, that sounds pretty good. Thanks so much for the talk. It's really comprehensive.
Yes, couldn't be a bit more in depth. Like I say, AWS, it's a lot to learn, but it's a good start. And like I say, later I'll share with you the project. You'll be able to take a look at that, use it in your own code, test the deploys. Use the $20 that's been given to you from AWS. Trust me, when you're testing and learning this, that $20 is really going to help you be able to practice for like a month without using all of it.
All right, thanks so much, Ken. Right, so that was Kane's AWS CDK talk. Next up, we have data query patterns in Rails by Louis.
Hi guys, can you hear me?
Yep.
Okay, cool. Okay, let me set up a bit. So to start with, I'd like to make this a little bit of a discussion. So if you guys have any comments or questions or feedback, please do feel free to jump in anytime you want and let me know. I'll be looking at the slides, so you might need to prompt me if there's an incoming comment.
Yep, no worries. I'll let you know.
Okay, so let me start. Give me a while. I need to set up. Okay. Okay, my name is Louis. I work at a small startup called Speedbrick Solutions. We build and operate a SaaS product for construction contractors. So our
Louis,
current
sorry, are you sharing your screen?
Yep. Am I not?
Yeah, it's not showing up here.
Okay, let's try this again. Okay.
Okay, you see it now, right?
Okay, got it?
Yep, looks good.
Got it?
Yep. Yeah, we can see it.
Okay, cool. Sorry.
Nice.
Okay, I mentioned that we built a SaaS product for construction contractors, and my current focus is building a lot of analysis tools for them. So to give them insight on all the data that they have collected. So I'm building charts and stuff, and it involves a lot of data querying. So I noticed quite a number of patterns over the period of time that I've been building this, and a lot of things, small and big. There are little pain points here and there. Okay, so when I think when all of us started with Rails, querying the data is really easy. You don't even need to know SQL. All you need to know is to either call find or call all. And as it scales, things are still really easy. So it's a gentle introduction from not knowing any SQL to writing your own full SQL queries and then pulling data out of Rails. But of course, it gets there are some side effects to it. So what usually happens is that once your data grows beyond a certain size, on development you won't have any problems, but on production you are going to start seeing your page load times go up, and this is usually due to either n+1s or you are loading a few thousand active record objects or more from the database, or you're using so much memory that the server is swapping like crazy. The memory usage can also trigger other funny behavior. So you'll trigger GC runs, garbage collection every now and then. So most of the time, your queries are your requests are going to be okay. But then when you hit a GC, then suddenly you'll have one or two requests which are abnormally slow, and it's going to be almost impossible to figure out why did it happen for that particular case. So it's a bit tricky to troubleshoot this kind of thing. I recommend a good monitoring add-on. I like using Scout. Another issue that I notice when handling querying data is actually I end up with little bits and pieces of code all over the place just to deal with the results of my handling queries. So I mean, inside the controller, I may have a call which has like 5-6 lines of code, maybe one random SQL fragment thrown in. So it doesn't look good. It's a bit messy, and when I come back and I try to understand what it does, it's a bit tricky. I've noticed that querying data usually follows a few different levels of evolution. So when you start building out a new chunk, then it's simple. Everything is available in one single Ruby object. So you just need to call find, and then you have everything there. You don't need to do any querying. All your associations are set up, so you just call association. You just pull your value, and that's it. Then at a certain point, you're going to realize that that's not efficient. That's a bit slow. Then you start to do some preloading in the controller. So you do some joins, some inner joins. You do some left join. You call includes for Rails to left join and populate the data that you want, and then things speed back up again. After all, you realize that okay, what you actually need is a bit more complex than what Rails provides out of the box. Then you start to add in your own SQL fragments, maybe to do some counting or do some sums or to do some non-standard queries. And at a certain point, you realize that it's getting so complex that it makes sense for you to just pull that chunk out and move it into a whole separate object of its own as a query object, which under the hood, it can be using Active Record, or you can be writing SQL directly. So these are the typical patterns that I've experienced. Anybody experience anything? Any other useful patterns? I guess we'll discuss that a little bit more later. So I talked about basic Active Record calling. So it's the most simple version, and it's awesome. When you're only loading one single record and its associations, it works very well. So this would be an example of what usually happens when you are just doing everything in a basic Active Record. Can you guys see this? Is it big enough?
Yeah, I think Louis, maybe you want to zoom in a bit more.
Okay.
Yeah, I think this is good. Thank you.
Okay, so as I said, my domain deals with construction. So we deal one part of it deals with contract progress claims, progress certificates, and payment for progress certificates. So how this works is that when your contractor is building a house for you, so let's say you are the client, the contractor is going to start work. Every month, he's going to submit a progress claim to you saying that I have completed this much work. And then after he submits it, you get an engineer to look at the claim, certify that, yes, you have completed this much work, or no, you have only completed this much work. And after the engineer issues a certificate, then you issue a progress payment based on the progress certificate. So every month, the figure will be cumulative. So if I issue my progress claim in January, that is all the work done in January. I issue my claim in February. That is all the work done in February plus all the work done in January. So the latest claim or certificate is always going to be the effective one. So as a contractor, the most important thing for you is to always keep an eye on your cash flow. I'm spending this much money to build a house for my client. I need to know how much have I claimed from my clients, how much my client has certified me, and how much my client has paid me. This is information that I need to be able to see very frequently. So within our app, we show it in quite a lot of different places. It's not just in one single place. The implementation is quite simple. So let's say I need to see what's the latest amount that I've been what's the latest certificate that I have received. What is the amount that I'm entitled to collect from my client? So I'll go through progress certificates. I'll query for the last one, and then I'll pull the certified amount. And the certified amount is a derived field. It's not a simple amount. It's composed of a bunch of other different fields. This works fine. This works without a hitch when I'm showing one single contract. But let's say I'm showing a view where I'm loading five different contracts, or I'm viewing subcontracts, and I want to see the certified amounts for each of them. Now this starts to become an issue because all my calculation code is in Ruby, and it's going to be very inefficient if I just call it like this. So we then move to the second part, the preloading part. Preloading usually works when we are dealing with collections of parent records. So I'm looking at 10 different contracts, and I don't want to have an n+1 issue when I'm loading 10 different contracts. So I preload everything. The benefit of it is I still manage to keep it simple. I still maintain the original interface. I don't need to change any of my code. But it doesn't play well in certain situations, as we will see. So this is the exact same code, but now we want to be able to preload it inside our index action. So in our index action, we call the exact same thing. We call contract.includes progress certificates. So what this is going to do is it's going to load. Let's say I have 10 contract records. Say I have 10 contracts in my system. Each contract has 10 progress certificates. So what this is going to do is it's going to load 10 contracts into active record objects. It's going to load 100 certificates into active record objects as well. So I'm going to end up with 110 AR objects here. Then for each contract, when I want to display it, I'm going to go through each of them in using Ruby, sort them by the date. Oops, this should be date. And pull out the last, and then pull out the certified amount from that. So as you can see, certified amount is still on the model. The business logic here hasn't changed. The only thing that has changed is this scope, because when you preload, it doesn't play well with scope associations. Each scope association will trigger a new query, so that would defeat the purpose of preloading in the first place. This is a bit. This is quite easy to use. You only need to be worried about how many objects you are loading, and that usually doesn't come out at the beginning. It's just after you use your system for a while, you end up with a lot of child objects, and then your memory usage is going to go up. This can also be a bit hard to troubleshoot because your distribution is never even. So I have something called a material list inside my system. So for most material lists, they load. The endpoint can load under 300 milliseconds. But I noticed that there are some cases where loading is going to take around 4 to 5 seconds. Why? Because those particular material lists load like 10-20,000 active record objects, which I think came up to around 300-400 megs of memory when somebody hits those the endpoint for those particular records. But it doesn't happen for most of them. So when I was troubleshooting it, it's like there's no problem with this code. Why? What's the problem here? Until I managed to catch a trace for that particular instance. Then that goes to the next part. So now we are going to load a lot of information. It's a lot more efficient to do some of it in SQL. But now we are making a trade-off. We want to reduce the amount of memory that we are using on our server. We want to reduce the amount of processor time we are using. What we are going to pay for it is complexity. Our code is going to get significantly more complex because now we instead of loading everything and doing our easy calculations in Ruby, we have to mix it between Ruby and SQL. These SQL fragments are also a bit painful to compose, and when you mix active record and SQL, the resulting mix is not easy to comprehend on first glance. Another issue when you start doing this is that it becomes unclear. When you look at it from the view has access to this value, but when you look at the model doesn't have that value. So if it's a chunk of code that you haven't looked at recently, it's like, where the heck does this come from? Let's look at an example of that. As I mentioned just now, my contractors want to look at how much, what is the latest certified amount that they are entitled to. They also want to look at how much have they been paid. So to pull that, I need to do a join in SQL, because this is going to be really inefficient to do in Ruby. So I'll select from my contracts table. My main model is still contracts. I'll do a left join through progress claims, progress certificates, and progress payments. So I need to do a left outer join here. Left outer join loads everything, but I need to do that because if I have contracts without payments, I do an inner join, it will exclude those. So that's not going to work. So what that turns into is a little active record fragment, which calls left joins, select coalesce some payments amount, group contracts ID, distinct. I also need to have the distinct because left outer join always returns multiple records. So now when I read this, it's hard to understand what is going on. Like if when I read the SQL starts with select distinct. But I look at the relation. Well, I could recompose it. It still doesn't. Okay, it reads a little bit better, but it's a bit hard to tell what's happening under the hood from just by looking at the relation. And this is one single SQL fragment to load one single field payment amount, but I have to do three joins over other tables. So now imagine what will happen if I need to turn this into a SQL. I need to load this through SQL as well. So I need to join with a progress certificates table. I need to sort it with certificate date, and then I need to pull the last record out. That's a bit tricky, as we'll see in a while. When we do that, it's easier to combine everything into a single object. So that becomes our query object. So now instead of combining 2 or 3 different queries, we compose everything into one big query and encapsulate in one class and write everything there. That's a nice place to handle all the little edge cases that we have. That's also a nice class for us to unit test. But the problem with this is that now we are adding, it's a trade-off again. Now we have a new object that our controller and view layers need to be aware of. So previously I can just call contract dot payment amount. Now I have to be aware of my contract query object, and then I need to load that in my controller. I need to load that into my view. So another issue with query objects is organization. When we say query object, it's just an object which encapsulates SQL queries. That's an implementation. But what do they actually do? To me, query objects are a bit too vague, because if you think about it, every active record model, it is a query object on its own. It can become a query object. So does that mean a query object should go into models? Then let's say we are doing something like we are querying a report. It's something that's not naturally a model. It doesn't really belong in our domain as a model. Maybe that might go into our queries folder. Then maybe you may have object which handles search. So search is the function is a bit defined, but it's not something that goes into your models as well. It feels a bit higher level than just a pure query object. So maybe that might go into lib. So organization gets a little bit confusing right here. I don't have a good answer for organizing query objects, because I don't have a good definition for query objects in the first place. So we saw this fragment which pulls payment amount. And then we have another chunk here which needs to load latest certified amount. So what happens when we want to load both of them together? Because if we combine these two, it's going to be very inefficient. The contract is going to have to do this includes, then the contract is also going to have to do an additional chunk of SQL statements to join payment amount onto this. So we can combine that we can combine it into one single query using a query object. To me, query objects are they encapsulate a bunch of SQL. They return you a group of Ruby objects. That's it. Active model happens to be very useful for this kind of thing because it allows me to define what my query object looks like. I can declare attributes on it. So I'm defining a contract that when I have a contract summary object here, it will respond to contract ID with an integer. It will respond to certified amount with a decimal. It will respond to payment amount with a decimal. I also use it to implement a active record like API. So it responds to where, it responds to find, it responds to all. So but when you pass whatever you pass in has to be the raw contract ID. So I don't want to support passing in the active record object because when you're dealing with a query object, you're actually dealing closer to SQL. You're not dealing with a Ruby object anymore, even though it's a nice wrapper. So that's the outside. How it's implemented is through an inner object which encapsulates the SQL query itself. The query just initializes a bunch of contract IDs. It will use active record connection to execute this SQL and return the results. That's it. But how it's implemented, I have a long SQL statement here defined inside a SQL template. So this template does the heavy lifting. So it's very easy to read. I like how Sublime Text and I think other editors will do that as well. They will highlight it when you put SQL chunks into your Ruby code. So I do the same thing, contract ID. Now last progress certificate, I have a subquery which pulls that one out. So that allows me to get certified amount. Total payment, same thing. I have a subquery which sums it up. So I just need to select total payment and that's it. So I'll select it from contracts and my subquery does all the heavy lifting. So for progress certificates, I'm using something pretty useful, which is a Postgres specific feature called distinct on. Distinct on is very useful when you only want to select one record from a group of records. So in this case, I want to select the latest one. So I'll select distinct on progress claims contract ID, and I will order it by the contract ID and the certificate date. So that will give me the latest one. This gives me a nice little subquery which matches one-to-one to each contract. So I can treat my contract as each contract is going to have one result inside my query. Same approach with progress payments. Previously, I have a query here. I just group this. I just wrap this inside here as a subquery, which now I can use inner join instead of outer join. I group it by contract ID, and that wraps it nicely. So this is my SQL. I just use it. I interpolate it, pass contract IDs in. I execute it using active record connection, active record based connection to execute it, and then I pass it up to my parent object, which runs it, and loads the result into contract summary objects. So this wraps it nicely for my view view or my controller to consume. But again, we end up with a complexity issue. If I have 10 query objects, then the rest of my application needs to be aware of all these query objects. A few other patterns that I would like to discuss, which I don't see as much literature on it. People don't talk about it as much. One of it is preloading. So I want to keep. Now I have query objects, but I don't want my query object to be the main thing in my application. I want the central part of my application to still be my models. So to do that, I load everything using my query object separately, and then I inject it into my model. So the rest of my application can remain ignorant of my query object. It's just an internal implementation detail for how I query it. But if I do that, I need to be careful about how I do it. So my model needs to respond to, say, later certified amount anywhere. But how do I know whether I have loaded it using a query object? So that requires a bit of a fallback handling. And null objects are actually pretty useful in this case. So in the previous case, I would have used a contract summary object to load my query. Now, what I do is, for every contract, I match it with a contract summary, which when I call contract summary, it will just call contract summary dot find by. Oh, yep. So it will pass it will pass the ID in, and then it will load the contract summary for this particular contract. So when I'm inside a show view, I can just call contract.find, and then I will have access to certified amount or payment amount inside the contract without having to do anything. So it feels transparent. My controller and view don't need to be aware of how it does it. But in the off case where I need to do it a bit more efficiently, now I'm loading a collection of contracts instead of one single contract. So now I use the where method that I defined earlier to load a bunch of contract summary objects. And then I go into each contract manually and find the loaded one, and I assign it manually. This requires a bit more work when I'm dealing with a collection, but this is the exception, not the norm. I probably have like 10, 15 views where I need to access a certified amount from a contract. Those views, I don't need to do anything else. I have maybe two or three views where I need to deal with a collection of contracts. So these views are the ones where I do a bit more work in the controller. So that's those are the techniques that I find the most useful so far. Another thing that I like to discuss is caching. I've also tried caching, but so far, in most cases, it hasn't been the right solution for me. So let's say I have an endpoint which is taking 7 seconds to render, and that 7 seconds is because I'm loading a crap ton of objects. I'm parsing it in Ruby, and then I'm generating a lot of markup in Ruby to render. So now I fragment cache this chunk of code. It should be faster, right? But in actual fact, it doesn't make it faster because I am still doing all that. I'm still doing all that work in Ruby to load a few thousand objects. I'm still doing all that calculation in Ruby. I'm still spending all that server memory to hold all these objects. What I'm saving here for fragment caching is the time to render this few hundred objects, but that actually does takes that saves some time, but it doesn't really save all enough time. And furthermore, it saves it for in some cases, but if the volume of data increases, the problem comes back. So it may take me 3 seconds to render this page. I fragment cache it, the time goes down to 1.5 seconds. So or even 1 second. 1 second acceptable for now. So I'm happy. 6 months down the road, volume increases, the problem comes back. Now it takes 3 seconds, and I'm back at square one, and I have to maintain my fragment caching, which happens to be quite painful to handle as well. Fragment caching has brings one of the two hard problems in computer science. The first one is naming. What the hell do you name your objects? I can never get that one right. The second one is, now you have a fragment cache. When do you how do you invalidate the cache? I have my giant complex query. How do I know that one of these things that I cache is should be expired? It's not valid anymore. I need to pull a new copy of it. And of course, the third problem is off by one errors. I'm addressing item 0, 1, and 2 here. But caching is necessary if you are aiming for very high performance. So if you want your response times to be consistently under 100 milliseconds, then yep, caching is necessary here. So that's most of what I have learned over the past few months. Some of the things that I really like from what I learned is number one is here doc highlighting. If you use SQL as the here doc string, okay, then your editor, I think Visual Studio does that. Sublime Text does this. I don't know whether the other editors do it. So if I call this, if I call my here doc something else, okay. It doesn't get the highlighting. But if I call it SQL, or I start it with SQL, then I get it highlighted. But if I move the SQL somewhere in the middle of the string, template SQL works. Okay. So it looks like as long as I have, it needs to be either at the beginning or the end. So as long as I have SQL at the beginning or end of the here doc, then I get this nice highlighting for long SQL queries, which is awesome when you are dealing with a complex nested query. Another very useful thing is left join plus subqueries. So I'm loading one contract. I want to be able to left join it with a subquery which is grouped. Okay, this thing on will return one record, or I group it by contract ID, which will also return one record for that contract. So that gives that allows me to encapsulate the complexity of the subquery inside the subquery. The rest of the query only needs to worry about loading one single contract, and it will be it will return the correct number of records here. Select distinct on was the other one that I mentioned, and then there's also count all. So if you notice, when you use SQL fragments, most of the time it will break something. So this is a bit of code that I have. So if I call it with line total dot to SQL, let me zoom in. So what I'm calling here is there's a SQL fragment which calls select some purchase order items. So if I try to count this, it doesn't work. What does it do? So it just tries to select count. It just wraps the sum in count, and then Postgres pukes because its syntax is incorrect. But if I use all, it works. In this case, it seems to work correctly. In some other cases, it's a bit smarter than that. It will actually count all the attributes that all the columns that you selected. So this is a lot more useful when you are calling it with a SQL fragment in Active Record. Okay, so that's about it. Any questions or remarks?
Right, thanks Louis for the talk. That was really, really insightful with active record and preloading and even caching. Like I said, it's one of the hard problems in computer science.
Yeah.
Yeah, I don't see any questions so far. Has has a few comments on while you're giving talk, like database views and also having sort by, but he didn't have any questions. Yeah.
Sorry, what were the comments?
Right, Has was saying hi, and then he was talking about like database views, and he was booing sort by.
Yeah, I know. That was on purpose because when you are using includes, then you can't use SQL order there. Then you have to change it back to sort by just to get includes to work. That is the easiest solution, but then it becomes inefficient. So you need to know when is it worth applying. If you only have a handful of associations there, why not? Of course, if you have like a few dozen, then that's a different story. And yeah, SQL views are pretty useful as well, but they add an additional layer of complexity, which I think it depends on which stage of your product you are at. If your product is already mature, you have a large amount of data, you have you have constant fixed requirements, you know what you're going to build, then sure, crystallize it into a SQL view. But if you are not quite ready yet, you are still experimenting, things are going to change, things are going to break, then I would rather just keep it as part of the query first. So when later down the line, when I know exactly what I'm dealing with, then I can convert it into a view. Then it makes it easier. Than to me, having a SQL view is it's on the same order as caching. Either I'm just caching it in the database, or I cache it in my model controller or front end. It's the same thing. It speeds things up, but it's complexity that I need to maintain further on.
All right, good to know. I have a quick question on the preloading part you mentioned. If I'm not mistaken, you mentioned that the controller has to do more heavy lifting. Have you tried it in like a real world example, like to see how much it impacts the controller?
Not to say that the controller has to do. When I talk about heavy lifting, when I talk about preloading, the question is just where does the code go to? So when you if you use a normal query object, then now your controller needs to load a query object along with your main resource. So now I would have a contract object, I will have a contract summary object as well. then now my view would have to be aware of a contract object. My view will also have to be aware of a contract summary object. So when I do the preloading method, I load everything onto contract. So the rest of my application doesn't care about the query object. All the rest of my application knows about is the contract object itself. But there is a little bit of complexity involved, and that would be worst case scenario. It depends on the number of records that you are loading with that technique, because you are iterating over in the case that I showed. I'm iterating over a collection of contracts. I'm also iterating over a collection of contract summaries at the same time. So I think the performance for that chunk would be big O n square. If I'm only dealing with a handful of it, I'm dealing with like 10, 20 contracts, then that's to me that's acceptable trade-off. But if I'm dealing with a few hundred contracts, for instance, then that would have a performance impact.
Right. But you mentioned that will be in some sense an edge case as well, right? Because you're more like catering for getting the
yeah.
The summaries.
So what I like about that pattern is that in most of my application, it doesn't matter whether it's at the controller level or it's at the backend level. I'm calculating something in the worker. I'm calculating something from another model. That query becomes seamless in most cases. So anytime I call contract later certified amount, it will trigger that query once in the transaction, and it will give me that value as many times as I want it without having to trigger another query. And the benefit is also I can call all the values that I triggered in that query object, and I get all of them with one single query.
All right. Thanks, Wei. This was very, very insightful.
You're welcome. I hope you guys enjoyed it. Feel free to drop me any questions or just post it on the Facebook group. I'll probably see it.
All right. Thanks so much, Louis.
Thanks, guys.
Okay, so that was data query patterns in Rails by Louis. Right, now that we're ending up, I wanted to talk real quick about bringing back Code Clinic. Previously, we had run a few Code Clinics in person when we have these meetups physically. But now that because of social distancing, we're doing online meetups, I'm thinking about how to bring back Code Clinic. Yeah, I'm not too sure what's the format we want to run for this. All right, we could do like a huge Zoom call and get topics, and then we just break out to breakout rooms, and after like 1 hour is over, everybody can join back and just debrief about what they've done, just on top of my head. But if anyone has any ideas, right, feel free to join our Slack and discuss about this. Personally, I don't write Ruby at work, right? So in the past few Code Clinics, I really learned a lot. So I really want to bring this back as well, to get the community together, writing Ruby code as well. So yeah, like definitely welcome any ideas. Post them up in Facebook or Slack. Let's see. Right, so that's all. Gui, is there anything you want to wrap up with?
Nope, I'm good. Yeah.
All right. I will just leave this here, right? Remember to get your credits. If you haven't, there's still a chance for you to get AWS credits. But thanks everyone for joining us today. Right.
Bye.